Every day you eat approximately 1 kilo of food and drink 2 liters of water. But you also breathe 25,000 liters of air every day. We place very high quality demands on our food and drinks, but the quality demands we make of the air we breathe are not as harsh. The air around us contains pollutants. These are produced both in nature and as a result of man-made processes. For example, industrial processes and combustion generate dangerous gases and particles that have a negative effect on us. And although industry is doing a good job of filtering out the larger particles, more often than not, the really small particles escape via smokestacks. It is the small nanoparticles which penetrate deep into the respiratory system, where they have proven ability to endanger our health. Nanoparticles range in size between 1 and 100 nanometers. 1 nanometer measures 1 millionth of a millimeter. But it's not just industry that generates harmful particles. Trucks and cars, especially those with diesel engines, may emit large quantities of nanoparticles and dangerous gases. Polycyclic aromatic hydrocarbons, or PAH for short, are formed during the combustion process. PAH occur both in gaseous form and bound to particles in the air. Road transport accounts for the largest proportion of total particle emissions in Europe. People who live close to busy roads are exposed to PAH and particles which may in the long run cause allergies, cancer, dementia, asthma, and other lung and cardiovascular diseases. We spend more than 90% of our time indoors, at work, or in the home. And polluted air is also a major problem in city centres. Most buildings in Sweden lack efficient air purification systems, allowing dirty air to enter our homes and workplaces through windows and ventilation systems. New research has also uncovered a link between exhaust fumes from cars and dementia. But how are we affected by polluted air? Natural defense systems such as our mucous membranes and cilia make it very difficult for the larger particles to enter our lungs. But nanoparticles and gases are able to get past the cilia and travel further down into the lungs, sometimes reaching the alveoli. From here, they're able to enter the bloodstream and cause allergies, cancer, dementia, and cardiovascular diseases. The World Health Organization (WHO) has classified air pollutants such as diesel exhaust gases and particles as carcinogens. WHO also worked with the OECD, Organization for Economic Cooperation, to estimate the total cost of the illnesses and premature deaths attributable to air pollution as being $1.6 trillion by 2010 in the European region alone. For us at Camfil, cleaner air is of the highest priority. Working with Stockholm University, we have conducted a study to determine how different types of filter material manage to filter out PAH, a group of hydrocarbons of which most are carcinogens. Stockholm University is a world leader on research into PAH. The Ames test can be used to biologically determine whether the air contains mutagenic substances. A unique set of measurements were undertaken on a heavily trafficked street in Stockholm and on the motorway close to a high school. The test showed that it is the particle efficiency of the filter which determines whether the PAH are removed. A filter with 50% efficiency was also shown to reduce PAH by at least 50%, while a filter with 80% efficiency reduces PAH by at least 80%. Dirty air affects our entire society. According to WHO, 2 million people die prematurely each year in Europe as a result of polluted air. 30 million extra sick days are also attributable to air pollution. However, many diseases such as allergies, cancer, dementia, and cardiovascular diseases could be reduced. But to do this, we must jointly begin to take the problem of air pollution seriously. The Camfil and Stockholm University study has been ongoing for several months, with various researchers and institutions involved. The test shows that a filter with at least 50% separation of 0.4 micron particles is required to achieve a significant reduction in mutagenicity. Consequently, common M6 filters with 10% separation are not sufficient. According to the European standard EN779, an F7 filter must have at least 35% separation of 0.4 micron particles, while P-marked filters have a minimum requirement of 50%. It is therefore important to select an F7 filter with at least 50% efficiency. Our measurements show that Camfil filters are 43% more efficient than required by the standard. The study in Stockholm has been completed, but our work on cleaner and healthier air continues.